Hello everyone. This video is on the Knewton Alta assignment, section 2.2, part 2, titled Solve Rational Equations. In this video, I'm going to be going over a version of this Knewton Alta assignment. Now please understand that the questions I see in this video may or may not be exactly the same questions that you see when you work on the assignment yourself. But the objectives are the same, so the questions should be similar, and the way you would work on them would be similar. So I'm hoping that watching me work on these here help you out, when you're working on them on your own. Alright, so here's your assignment page. Again, you won't see the words preview of, you'll just see the title. Got your mastery bar, telling you how far along you've gotten in the assignment. You can view your objectives. Looks like there are 3 objectives in this particular assignment. Then under the current objective, there's a question related to that objective. And at the bottom of every question, you should see a few buttons. There's the feedback button, where if you see a typo in the question or something's wrong with the answer or something, you can send feedback to Knewton and hopefully they address it and help you out and fix things. You will not see this instructor cheat button, right? This is for me only. And you will see a more instruction button, which you can click on if you're struggling with a particular objective or a question. And it'll take you to some reading or some videos or both related to that objective, and then you'll be given some questions related to that instruction, and you can get through the assignment that way if you wish. Alright, so this first question is on the objective: solve a rational equation, binomials in the denominator. Well, it really doesn't matter what's in the denominators. Rational equations are just equations basically with fractions in them. But here we're going to see some of these fractions have variables in the denominator. But the way I'm going to go about doing this first one is the same way I'm going to go about doing all of them for all 3 objectives. Right, so I'm going to write out this equation we're given here and talk about the process. Alright, so this equation is you got 1/2 plus 3 over x minus 3 equals, and then negative 3 over x minus 3 again. Okay, so the first step I would do is factor all the denominators completely. And that step is already done here. You can't factor 2 any further or x minus 3 any further. Factor all denominators completely. Done. Then I would state any restrictions on the variable. So for example here, x cannot be equal to 3. And why is that? Remember, denominators can't be equal to 0. You can't divide by 0. Denominators can't be 0. So, x minus 3 can't be 0. So, meaning that x can't be 3. And that looks like the only restriction here. Alright, then we're going to find the least common denominator, which I have abbreviated LCD in previous videos. Least common denominator. Now to do that, you just simply list the denominators in factored form. There's 2, there's x minus 3, and that's it. and put different factors in different columns, and then the LCD is made up of just the product of all the factors that show up in these columns, 2 times the quantity x minus 3, or 2x minus 6 if you distribute. All right. And you'll see other examples of me doing this in further examples, all right? Further questions. All right, and then it becomes just like in section 2.2 part 1, when I had equations of fractions in that video. I found the LCD, and then you multiply both sides by the LCD. Okay, and this should clear your denominators away. All right, so got the whole left side in parentheses, right? The entire left side. Equals, and then again the right side, negative 3 over x minus 3. And we're multiplying both sides by this LCD, this 2 times the quantity x minus 3. Now on the left side, I'm going to be distributing. There are 2 terms. Each of those gets multiplied by the LCD. On the right side, there's just the 1 fraction, just the 1 term. And again, the whole reason for this is to get rid of the denominators. Right? You'll see that when I'm done with this, all the denominators should be gone. Right? So I have 2 times x minus 3 times 1/2 plus 2 times x minus 3, right, the LCD, times 3 over x minus 3 equals, and then over here you can very easily see the x minus 3's canceling. There's a factor of x minus 3 in the numerator and denominator. I'm left with just negative 3 times 2, or negative 6. And then hopefully you see the cancellations here. On the first term over here you have 2's canceling, and I'm left with just x minus 3 times 1, which would just be x minus 3, so there's really no need for parentheses there. Now if it was x minus 3 times 2 or 3 or something, I have to distribute. And then the second term, you see the factors of x minus 3 canceling, and I have 2 times 3 left. That's 6. So look at this. I got x minus 3 plus 6 equals negative 6, and see what happens when you multiply both sides by the LCD. Fractions are cleared. All right, the fractions are cleared. You have no more denominators. And then I'll just say at the end, solve the resulting equation for the next step. And the last step should be, check your solutions. And you always check your solutions back in the original equation. Well, you see, this is just x minus 3 plus 6. That's x plus 3 equals negative 6. Subtracting 3, we get x equals negative 9. There's our possible solution. And then, of course, finally, like I said, check in original equation. All right. So going back to the original equation, that was this here. I'm going to replace x with negative 9. So we have 1/2 plus 3 over negative 9 minus 3. All right, replacing x with negative 9. And is this equal to negative 3 over negative 9 minus 3? All right, well, let's see. This left side is 1/2. Now this is 3 divided by negative 12. 3 divided by negative 12, that would reduce to negative 1/4. So plus negative 1/4 or minus 1/4. And then over here, 3 divided by negative 12 is negative 1/4, but then times negative 1 would be positive 1/4. And this is true. 1/2 minus 1/4, that's 2/4 minus 1/4. When you get a common denominator, that's 1/4 on the left, 1/4 on the right. That works. All right, so this x equals negative 9 is a valid solution to this equation. And I'm going to be following those same steps every single time. And notice it says do not type in x equals. All right, just put the number. Negative 9 is our solution. And then after every question, it'll tell you if you got it right or wrong, and then they'll provide you with an answer explanation. Please read through the answer explanations, whether you're right or wrong. If you're correct, just glance through them, make sure you got it right for the right reasons, that you didn't just get lucky. You understand why you were right, right? Or, maybe they do something in a different way that you like better, and then you can use it in the future. Now, definitely, if you got it wrong, read through the answer explanations and make sure you understand why you were wrong so you can fix it in the future. Okay, next question. And again, I'm going to be doing this basically the same procedure for all these problems. Right. This is same objective as the last one. So we got these two fractions equal to each other. We're solving for x. So once again, I'll write this out and follow the same steps I followed for that first equation. Right, and I'm going to follow those same steps every single time. So now we have negative, 2 over x equals negative 5 over x minus 6. And personally, I don't like these negative signs on both sides. Just multiply both sides by negative 1. So then we have 2 over x equals 5 over x minus 6, just to get rid of those negative signs. I can multiply both sides by negative 1. That'll get rid of these negative signs. Okay. All right, so remember the first step is to factor the denominators. The denominator, now they're already factored, so that step's done. The denominators are x, and in the next row, x minus 6. And again, I'm putting the different factors in different columns. And then the LCD is just just every factor that shows up in a column shows up as a factor of the LCD. The LCD is x times x minus 6. Now, one thing also I want to point out is that x can't be 0 or 6. Just keep that in mind, all right? Because if x were 0, this denominator would be 0. And if x were 6, this denominator would be 0. All right. All right, and then I multiply both sides by this LCD. Now, the nice thing is both sides only have a single fraction. So the left side times the LCD, the right side times the LCD. And again, the whole reason for multiplying both sides by the LCD is to get rid of the denominators. You see the x's canceling on the left. So I have a x minus 6 times 2, and I'm going to be distributing that 2. Right? Equals, and over here, the x minus 6's cancel, and I have just 5 times x. And then we solve this resulting equation without the denominators, and then check our solution. This is 2x minus 12 on the left side equals 5x. Right, and then subtracting 2x, I get negative 12 equals 3x. Dividing by 3, I get x equals negative 4. And then check it. Now, if you did everything correctly, as long as this number that you find isn't one of the restricted numbers, you should be good. This should work. And I'll test it out. If I replace x with negative 4, the left side would be positive 1/2, and so would the right side. Because you'd have 5 over negative 10, which should be negative 1/2, but 10 times negative 1 would be positive 1/2. You'd have 1/2 equals 1/2. This negative 4 is a good solution. All right, and they got the x equals already. Let's just put the number, right, negative 4. Wonderful. Okay. Next. All right, so now we have one with monomials. This is probably even easier. But I'm doing the same procedure. Same procedure. Right, so I'll write this equation out. I have negative 7 over 4x plus 5 over 6x equals 1. The denominators are 4x and 6x. Now you can probably already tell me that the LCD is going to be 12x. But I'll show you how to find it again, right? And the restrictions, x can't be 0, right? Because if x were 0, either one of these denominators would be 0. Alright, so again, the denominators, I'll just put dens, D-E-N-S, 4x. Alright, if you break that up completely, is 2 times x. I'm just listing every single factor. And 6x is 2 times 3, and I'll put 3 in its own column, right? Times x in the same column with the other x. And so the LCD is 2 times x times 3, which when you all simplify it is 12x, as I mentioned. Alright, so I multiply both sides by 12x. Negative 7 over 4x plus 5 over 6x equals 1. And both of these sides are getting multiplied by the LCD 12x. Gotta distribute over here. And that should cancel all the denominators. It should clear all the fractions. Now 4x into 12x, that's just 3 times negative 7 would be negative 21 for the first term. Plus, and then 6x into 12x is 2 times the 5, and the numerator still is 10. And then on the other side, 1 times 12x is 12x. This side is negative 11, right? Negative 21 plus 10 equals 12x. Dividing by 12, we get x equals negative 11/12. And check it. Now, as I said, if you know for certain you did everything right, as long as this number that you found isn't one of the restricted numbers, you should be good. Thumbs up on that. All right, so negative 11/12 should work, and I'll leave it to you to check it more thoroughly. But yeah, negative 11/12, x equals negative 11/12. Great. And again, please read through your answer explanations. Great. All right. Alright, now here's where we actually have to factor. Alright, I said step 1 back in the first example. Step 1 was factor the denominators, I mean, I factored the last ones too. I broke up 4 into 2 times 2. I broke up 6 into 2 times 3, but this one's a little more involved because you got a quadratic denominator here. Alright, so once again, write this out. So you have negative and then the fraction, 5 over x plus 1 minus and then 4 over x minus 4 equals negative and then fraction 7 over x squared minus 3x minus 4. What I'm going to do, again, because I don't like all these negatives, I'm going to multiply everything by negative 1, make everything positive, right? So this will be positive 5 over x plus 1 plus 4 over x minus 4 equals, and then multiplying this side by negative 1 as well, make this positive 7 over x squared minus 3x minus 4. Alright, now the denominators are, x plus 1, which is just x plus 1 when you factor it. That doesn't factor any further. X plus 4 is just x minus 4. X minus 4 is just x minus 4 when you factor it, and again I'm putting that in a different column. And then x squared minus 3x minus 4 factors to x plus 1 times x minus 4, right? And I'll put those under the same factor columns. So the LCD is just x plus 1 times x minus 4. And this is what I'm going to multiply each of these terms by. And I'm just going to do this time. I'm going to say multiply. I'm multiplying both these fractions on the left side by the LCD, the fraction on the right side by the LCD. Now on the left side, the 5 over x plus 1, when I multiply it by the LCD, the x plus 1s will cancel. I'll cover those with my fingers. And I'm left with 5 and x minus 4. I'm left with 5 times the quantity x minus 4. All right, then we got plus. And then when I multiply the second fraction by the LCD, the x minus 4s cancel. Cover those up. And I'm left with 4 and x plus 1. 4 times the quantity x plus 1. All right, so that's the left side after being multiplied by the LCD. On the right side, the denominator is the LCD. They'll both cancel. I'm left with just 7. Oh yeah, I forgot the restrictions. Sorry, x can't be negative 1 or positive 4. All right, because that'll make one of these denominators 0. All right, so as long as when I find my solution, as long as it's not negative 1 or 4, it should be good. All right, now I'm solving the resulting equation. We distribute the 5 here, the 4 here. 5x plus 4x is 9x. Then we have negative 20 plus 4, that'd be negative 16. All right, so the left side is 9x minus 16 after combining like terms. And then equals 7. Then I'm adding 16, get 9x equals 23. All right, 7 plus 16. And then dividing by 9, x equals 23/9. And this is as reduced as that gets. And don't forget to check it. All right, I'll leave it to you to check it out because it's kind of annoying. This is a little more complicated with all these variable places. But if you know you did everything correctly, and this number isn't one of the restricted numbers, right? It's not -1 or it's not 4. So this should be good. All right. So going back here, x equals 23/9. 23/9. Wonderful. Okay, and then again, please read through the answer explanations. All right, so we're still in this objective with, yeah. All right, so I'll write this out and do the same thing as the last example. So we have negative and then the fraction 3 over x minus 1 plus 5 over x minus 3 equals negative and then the fraction 1. So negative 1 over x squared minus 4x plus 3. Now I hope you realize that this is x minus 1 times x minus 3. It's just the product of the other two denominators. So that's the LCD. I mean, I'm hoping it's obvious. And the restrictions, x can't be 1 or 3, right? Because if x were 1 or 3, you'd be dividing by 0 in these denominators. You can't have denominators of 0. That's undefined. All right, so the LCD is the product of x minus 1 and x minus 3. And I'm multiplying that fraction, and that fraction. Right? I'm multiplying everything on both sides by this LCD. And that should cancel denominators, right? So the first one, on the left, you have x minus 1 cancels. I'll cover those up, leaving me with negative 3 times the quantity x minus 3. Plus, and then the second fraction, the x minus 3's cancel. I'm left with 5 and the quantity x minus 1. And then the other side, both factors cancel, the whole LCD, and then I'm just left with negative 1. And I solve this equation here. So distribute the negative 3, distribute the 5. Now negative 3x plus 5x is 2x. And then positive 9 minus 5 is plus 4. All right, 9 minus 5 is 4. So I have 2x plus 4 equals negative 1. Subtract 4, you have 2x equals negative 5. Divide by 2, x equals negative 5 halves. And this should work. It's not 1 or 3. So it should work. And again, go back to the original equation if you wish and check that out, but I'll leave that to you. And again, they say don't type in x equals, right? Just type in the number, the solution to this equation, negative 5 halves. Submit. All right, great. But yeah, you see I'm doing the same thing every time though? All right, finding that LCD, multiplying both sides by the LCD, solving the resulting equation, check your solution. It's very, very simple. Next question. All right, so now we have just some monomials in the denominator. Again, I'll write this out. Let's look at it. So we have 4/3 plus and 3 over 4x equals negative 5 over 6x. So hopefully it's obvious that x can't be 0. Right? Again, I'm not going to go through finding the LCD all the time. I'm just going to state it and leave you to find it. I'm hoping it's obvious again that the LCD is 12x. All right, 3 that's 3 times 4x, 4x times 3, 6x times 2. Then I multiply these two fractions, both terms on the left side, the one term on the right side. We're going to multiply everything by 12x. Now, 3, when you divide 12x by 3, that'll be 4x. 4 times 4x is 16x plus Then 12x divided by 4x is 3, times the 3 in the numerator would be 9. So you have 16x plus 9 on the left side after multiplying by the LCD. And then 12x divided by 6x is 2, times the negative 5 would be negative 10 on the right side. Subtract 9, you got 16x equals negative 19, divide by 16, x equals negative 19/16, which, there is no common factor in the numerator and denominator, so that's good. That's as simple as that fraction gets, and just make sure that that's not 0, which it isn't. And you can check it again. I mean, this one wouldn't be that hard to check by hand. Make sure that that's an actually valid solution, but it should be. So I feel like I did everything correctly. X equals negative 19/16. Wonderful. All right. All right, then we're same thing with the monomials. So again, I'll write this out, go through and solve. So we have negative 3/5 plus 7 over 6x equals 7 over 3 times x. Again, I'm hoping it's obvious that x can't be 0 here, because you'll have denominators of 0. Another thing I hope you find easy to find is the LCD. The least common multiple would be just 30x. That'd be 2 times 3 times x times 5, right? 30x. And I'm going to multiply everything, these two fractions, those both terms on that side, that term on that side. I'm going to multiply everything by 30x. So this ends up being, the first negative 3/5 times 30x. Well, 5 goes into 36 times, so it's negative 3 times 6x. That'd be negative 18x. Plus 6x goes into 35 times. 7 times 5 is 35. So the left side is negative 18x plus 35 after I'm done multiplying by the LCD. Then 3x goes into 30x 10 times. 7 times 10 is 70. And now I'm solving this equation. So I subtract 35. We have negative 18x equals 35, right? 70 minus 35 is 35 again. And then divide by negative 18. X equals negative, 35/18. Which this is 2 times 3 times 3. This is 5 times 7. They have no common factors. So that's it. And again, that's not 0, so should be a good solution. You can go back and check if you wish. I leave it to you, though. So the solution to this equation is negative 35/18. Cool. All right. Next, again, notice I'm doing the same steps every time. Another one where there are monomials. So once again, write this out. Got 4/5 plus 3 over 4x equals negative 1 over 6x. So once again, x can't be 0. You'd be dividing by 0 here and here. The LCD is 2 times 3. That's 2 times 2. That'd be 2 2s. That'd be 4. 12 and then times 5. Right. So 60x would be the least common multiple of all these, right? It's 5 times 12x, 4 times 15x, 4x times 15, 6x times 10. All right. Okay, and then multiplying both sides, every single fraction here by the LCD. Like I said, 5 goes into 60x, 12x times 4 times 12x is 48x, plus 60x divided by 4x would be 15. 3 times 15 is 45. So I have 48x plus 45 on the left. Then 60x divided by 6x is 10 times negative 1 would be negative 10. Okay, then I'd subtract 45. 48x equals negative 55. Then divide by 48. X equals negative 55/48. This is 5 times 11. 5 and 11 don't go into 48. So this is as simple as that gets. And check it. And it's not 0, so it should work. Right? If you're doing everything correctly and it's not one of those restricted numbers, it should work. So the solution to this equation is negative 55/48. Cool. All right, so one of the objectives is done. Moving on. Now we have, binomials in the denominator, kind of like the very first example from this video. So once again, just writing out this equation and solving it for you. Negative 7/6 minus 3 over x minus 6 equals negative 7 over x minus 6. Once again, got a negative sign in front of every term. I don't like that. So I'm going to multiply everything by negative 1, make it 7/6 plus 3 over x minus 6 equals positive 7 over x minus 6. All right, just to get rid of all those minus signs. All right, so I'm hoping it's obvious that x can't be 6, right? You'd be dividing by 0 in these two fractions. Again, easy to find the LCD here. It would just be 6 times the quantity x minus 6, right? Just multiply these two denominators, the only two denominators that are showing up. And then I'm multiplying every single one of these by the LCD. So in the first one, the 6's would cancel. I have 7 times the quantity x minus 6 left, plus the second fraction on the left, the x minus 6's would cancel. I'd have 3 times 6, or 18 left. And on the right side, the x minus 6's would cancel, and I have 7 times 6, or 42. Over here on the left side, I'm distributing the 7. So I have 7x, minus 42 plus 18 be minus 24. All right. Yeah, negative 42 plus 18. Yeah, it would be minus 24 equals 42. And then I add 24, get 7x equals 66, positive 66, and then divide by 7. So x equals 66 sevenths, and 7 doesn't go into 66 evenly, so this is as simple as this gets, and it's not 6. That is not 6, so that should work. 66 sevenths should work. And it says don't type x equals, right? Just 66 sevenths. Wonderful. But yeah, see, same steps every time. All right, it's getting kind of boring actually. I'm sure it will be with you as well. But this might be the first time you're seeing this. I don't know, so maybe it's not as uninteresting. I've practiced this a lot. You can probably tell. Anyway, so same objective here. Looks like the last question from this objective. So once again, I'll write out this equation. We have 2/5 plus 1 over x plus 6 equals 6 over x plus 6. Again, I hope it's obvious that x can't be negative 6, because if x were negative 6, you'd have zeros in these denominators. The LCD should also be pretty obvious. It's just 5 times the quantity x plus 6, or 5x plus 30. And then I'm multiplying everything by that LCD. On the left side, the 5's would cancel in this first one. You'd be left with 2 times the quantity x plus 6. Plus the next fraction, the x plus 6's would cancel. You'd be left with 1 times 5, or 5. And on the right side, you have x plus 6's canceling, and you'd be left with 6 times 5, which is 30. All right, then here distributing the 2, we have 2x, then plus 12 plus 5, so plus 17 equals 30. Subtract 17, you get 2x equals 13, divide by 2, x equals 13 halves. There you go, that should work. And that's not 6, or negative 6. That's actually positive 6.5. And that should work. All right. And I leave it to you to actually check it, but that should be good. So x equals 13 halves. Great. All right, now that objective's done. I should have just 2 more questions in this objective where you got the denominators to factor. All right, so once again, I'll write it out, go over the same steps as I have been for every single one of these problems, and we'll solve the thing. So I have negative 1 over x plus 3 minus 6 over x plus 1 equals negative 2 over x squared plus 4x plus 3. Now, once again, I'm noticing every single term has a minus sign in front of it, so just to get rid of those, I'm going to multiply everything, both sides, by negative 1. So that's 1 over x plus 3 plus 6 over x plus 1 equals, and then positive 2 over, and then x squared plus 4x plus 3 is actually x plus 3 times x plus 1. All right, just the product of these two. Now the restrictions are easy, now that everything's factored. X can't be negative 3 or negative 1. Because that'll make denominator 0. The LCD, again, I'm hoping is obvious, is just x plus 3 times x plus 1. And every single one of these gets multiplied by the LCD. On the left side, first fraction, the x plus 3's would cancel, and I'd be left with 1 times x plus 1. Well, that's just x plus 1. There's no need for parentheses there. All right, plus the second fraction, the x plus 1's would cancel, and I have 6 times the quantity x plus 3. And I do need the parentheses there because it's times 6. We're going to have to distribute. On the right side, both of these would cancel, leaving me with 2. All right. Now the denominators are gone. Great. Distribute the 6 here. 6x plus 1x is 7x. Then you have 6 times 3 is 18, plus the 1 is 19. So the left side is simplified to 7x plus 19. The right side is still 2. I would subtract 19. All right, 2 minus 19 is negative 17. Divide by 7. X equals negative 17 sevenths. And that should work. And that is not negative 3 or negative 1. So that should work back in the original equation. And I leave it to you to actually check that if you want. All right, but the solution to this one would be negative 17 sevenths. Great. All right, I should have just one more like this. Once again, I'll just write out the equation and go through the process of solving it. And you may notice, right, the process is the same for all of these. Doing the same steps I did in the first one. All right, so we have 1 over x plus 3 minus 7 over x minus 3 equals negative 3 over x squared minus 9. Now x squared minus 9, that's just x plus 3 times x minus 3. All right, difference of squares. So again, we have a denominator over here, that's just the product of these two. I hope you see the restrictions. X can't be 3 or negative 3 because I'll make these denominators 0. And the LCD is just the product of x plus 3 and x minus 3. Very easy one again. And I'm multiplying every single one of these on both sides by the LCD. Now the first fraction on the left, the x plus 3's would cancel, and I'd be left with 1 times x minus 3. That's just x minus 3. Since we're multiplying by 1, no need for parentheses there. Second fraction, you got minus, and then second fraction, x minus 3's would cancel, leaving me with 7 times the quantity x plus 3. And you need the parentheses there because we're going to have to distribute this now negative 7, not 7. Distribute the negative 7. Right side, both these factors would cancel, leaving me with negative 3. All right. Now on the left side, after distributing the negative 7, you'd have negative 7x plus x, that's negative 6x when you combine like terms. And then negative 7 times positive 3 is negative 21. Then you have the minus 3 over here. Negative 21 minus 3 would be negative 24. Then I would add 24. Now negative 3 plus 24 is just positive 21. Then divide by negative 6. That's negative 21 sixths. But this one can be simplified, right? They asked us to write a simplified fraction. Both these have a common factor of 3. If I divide each of these by 3, that's negative 7 halves. There's our solution. And that's not 3 or negative 3, so this should work. This should work, and I leave it to you to check it. Replace all the x's with negative 7 halves and simplify. It'd be a little hairy, but you could do it. I believe in you. This should work though, negative 7/2 or negative 3.5, negative 3.5. But they do ask us to enter a simplified improper fraction. All right, so going back here, and again, don't enter x equals, they just want the number negative 7/2. And there we go. And again, please read through the answer explanations. Great. And that should be it for this preview of this particular assignment. As I said at the top of the video, all right, please understand that the questions I saw in this video are not necessarily going to be the same questions you'll see when you get the assignment yourself, but the objectives are the same. The same steps are performed every time, right? You factor the denominators, list any restrictions, find the LCD, multiply both sides by the LCD to clear the denominators away, solve the resulting equation, and check your solution, right? As long as that final number you get isn't one of the restrictions and you know you did everything correct, that solution should be good. All right, I'm hoping that watching me go through these 12 examples here help you in some way when you're asked to, do the assignment or working on the assignment yourself. And thank you very much for watching.